Hey everybody, Mr. Kowalczyk here. So today we're going to do lesson 3.4, and I'm going to teach this one on video, kind of. So the 3.4 is going to be angles of a triangle. There's a couple things that I did want to say about this. So right away, the best angle from which to approach any problem is the triangle. Love it. Love this one. So good. Moving on, we have another one. Yay! So we've got equilateral, isosceles, and scalene all classified by side. And then homeboy pipes up and says, "You forgot the Bermuda Triangle." All right, so what were you expected to do already? Well, this past weekend, you were expected to take notes on triangles. Now, the reason why this is here is because what I want you to do is also see another joke, but I want you to get in the habit, or at least start to practice, your using the textbook as a resource, because all of the things that we're expected to learn in this particular section are in the textbook for you to go back to them and to go ahead and like just refer to them if you forget. So don't forget about that textbook as a resource. Don't just rely on the notes, okay? Like the notes in the slides that I post in Schoology. Now, we've got all of these things here, definition of triangle, vertex, and sides. In your textbook, one of the things that you might notice is that definitions are going to be in bold. So if you see bolded words in the body of the text, meaning the writing in the textbook, then you know those are going to be definitions. Now you're going to look for these three and this four, and this is our fourth one. And then we have definition of exterior angles and remote interior angles. I'm going to talk a little bit more about 7, as well as the triangle angle sum theorem and number 8 in just a minute here, because I want to talk about those and give you my explanation of them. You know, that's always better than the book. Maybe not, whatever it is. So we've got one, classifying triangles by sides and angles. This one's going to be important. There is a Quizlet in the 3.4 folder. So if you want to check that out, you can use that to get some practice classifying triangles by sides and angles. Definition of auxiliary line, and then we'll talk about these in just a little bit. Okay, so make sure you have all of this down in your notes, and I want to talk about 4, 7, and 8 right now. Okay. All right, so I have my blank piece of paper here, scratch paper. I want to talk a little bit about the number 4, which is the triangle angle sum theorem. So the triangle angle sum theorem, as we hopefully remember, is that if we have any triangle in the world, we know that if we have angles A, angles B, and angle C, we know that A, the measure of angle A, plus the measure of angle B equals, or plus, excuse me, the measure of angle C equals 180. So we know that that's true because of the triangle angle sum theorem, right? So that's triangle angle sum theorem, TAST. It's a great word to say. It's just sharp. All right, measure of angle 1 plus measure of angle B plus, this is plus, not equals, does not equal, plus measure of angle C equals 180. So now, what I want to talk to you about is an exterior angle. So an exterior angle on any side of a triangle is made by extending that side of the triangle. And then the exterior angle is going to be the angle that comes from that side of the triangle to the extended side, to the extended adjacent side. Then we'll call this angle E for exterior. Okay. So now, if we look at, and if we pretend that this part of the triangle or the system doesn't exist, so we forget about all of that, and we just look at this, well, what do we know about angle E and angle C? Well, hopefully you see that these two are not only supplementary, but they're also a linear pair, right? Because they're supplementary and they're adjacent. They share a common vertex and a common side. That makes them a linear pair, which tells us that the measure of angle E plus the measure of angle C is going to equal 180, because we also know that linear pairs are supplementary, which adds up to 180, and then adjacent. Okay, cool. So let's go back to our document, or excuse me, our diagram from before, and we can see this. Now we know A plus B plus C equals 180. we also know that C plus E equals 180. So if we look at these two equations over here, maybe you can see that the measure of angle C and the measure of angle C are added to both of them. And then we have the measure of angle E here, and we also have the measure of angle A plus B. So what that tells us is that if we were to use a transitive property, we could say the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle C plus the measure of angle E. And then, yes, you see where this is going. We subtract, use our subtraction property of equality. We subtract the measure of angle C from both sides. And then that proves to us, these cancel out. Then we have the measure of angle A plus the measure of angle B equaling the measure of angle E. So why is that important in this situation? Well, I wanted to show you where the relationship comes from that you took notes on before, which is the triangle exterior angle sum theorem, or TEAST, which is another horrible word. But basically what it means in this situation is that the measure of angle A plus the measure of angle B equals the measure of angle E, the exterior angle. Now, these over here we refer to as remote interior angles. Now, in this situation, with E being our exterior angle, A and B are the remote exterior angles because they're remote from angle E, right? They're not right next to it. They're not close as angle C is, but they're remote. They're farther away from this angle E, the exterior angle. That's why they're remote or far away from the exterior angle in question. So in this situation, we would take angle A plus B, and it's going to add up to equal the measure of angle E. And this is kind of not a proof, but it's a reason because I didn't give the reasons as to why the measure of angle A plus the measure of angle B equals the measure of angle E. All right, so that's TEAST, like I said, which is another terrible word, just awkward. It's an acronym. But I wanted to show you kind of where these came from before you jump into your practice problems. All right, so now for practice problems, what's going to happen today in class is that you're with the sub, and I want you to spend a half an hour on these next problems. So I'm going to give you 4 problems, and what I want to ask you to do is everybody's going to copy down these 4 different pages of problems to save paper. So station 1 is going to be proofs, and there are 2 proofs. So at this point, pause the video and copy down this first proof. Now this one is going to be easier, okay? It should be easier, and what you need to do is, using the fact that L3 is parallel to L4, you need to prove, and also that A is congruent to C. You need to prove that line 1 and line 2 are not parallel. Or excuse me, are parallel. I was jumping ahead of my thinking. Now, the only hint I'm going to give you is that you can't right away say that A is congruent to B, because we don't know that 1 and 2 are parallel to each other. So you have to kind of work around that and do some thinking with postulates and transitive and whatnot. Make sure you work on that first in order to get this. All right, so that's the first one. The second one, this is a proof. This is going to require an auxiliary line that's parallel to segment AC and goes through B. So this one is going to look, you're going to introduce a line that looks like this. And then you have, maybe we'll say point D here and point E here. And that'll be really helpful in this particular case. Okay, so pause that video, copy this proof down, and go to work on that, knowing that this is going to be a bit of a challenge proof. Okay, work on that one in your table groups. And then we've got 2 more pages of solving for angles in a triangle. Now in this case, we have 9, 10, and 11, and these are kind of the beginner problems where you're going to want to use that triangle exterior angle sum theorem, or TEAST, like I told you about, where we have A plus B equals E. So don't forget about that. So pause the video and copy those down. And then our last page is going to be this one here with 13, 14, and 16. Sorry, 12, 14, and 16, just the even numbers. So copy these down and go ahead and solve for x and y in each situation. All right, now with these, once you've solved these, I want you to do at least the first proof and then all 6 of these triangle problems. Okay, if you want to do the challenge proof, you can certainly challenge yourself and work on that. But after you've done the first proof and all 6 of these triangle problems, you can check the answers. They're in the 3.4 folder, in the 3.4 PDF notes. Okay, so you just have to scroll down and you'll see these problems marked up with the answers, so you can check your answers to make sure you did them right. And then after you're done with that, checking your answers, please go ahead and do this. This is your 3.4 homework assignment, which is due, I forget the due date, so check the due date. Check the due date. It's in Schoology. Okay, all right, that's that. Rock and roll, have fun, be nice to the sub. I'll see you on Monday.